There are also other fun things that contract binding created that we compiled earlier, including things like watch transfer, where if you wanted to see the progress of it on the blockchain, you could actually hook into that directly. And in our case, since we're using Go, that binding is typed, so you have a lot of hints when you're using it. And it's fairly safe to use. So now we're going to go to the second exercise. We're going to navigate to the mint.go file within package server. We're going to find the function called mint with bindings, and then you're actually going to do the mint transaction. So you'll be, after completing this, you will have minted tokens to your local blockchain with this ERC20 that we have just created all together. The code that you'll see, we're going to split this down in the following exercise, so that's why we have this mint function that will split between mint with bindings and then mint with like explicit transaction generation and everything. And there is a test that you can run to see if it's working. So if you run go test package server, run test mint, you can do some TDD style if you so choose. Cool. So I'll give you guys maybe 5 minutes or so, a little bit less, to try this out yourself. And again, as a reminder, if anyone is having any trouble, just raise your hand. Happy to come down and help. So this particular function, we required these two calls. The first one is to get the bindings that we have been hinting at before that give you a lot of convenience functions. And we have this method on the server called get USDK bindings. That will do everything for you. Feel free to read about it in the code to see how that works. And then after we have that, we're able to just call mint. And this mint call will take in 3 arguments. The first is the particular address to send the transaction from, in this case the owner, because the owner is the one that has the ability to do the minting. The second argument is the destination, where we want to mint to. And we have this little helper function here to convert from string to the format that that particular binding wants, that type. And then we have the amount. And here, like I had mentioned, since we're taking in a decimal, we want to convert this into the uint version of it, which we have this helper function to convert this into a big int. And then after that, this function call actually calls 3 different things. It creates the transaction, it signs it, and then it even broadcasts it as well, because it's already bound to that particular contract on the local blockchain, which is great and convenient, but not really the safest. You probably don't want to keep your private key in code or in your environment variable. You should probably keep it somewhere safer, especially if it can mint infinite tokens. It's definitely something you want to be careful with, which is why in the next exercise, Brent is going to take over and walk us through how we can actually separate these pieces out.
Cool. Thanks. So we're focusing a lot on the mint transaction here. We focused on how to put it together in the smart contract, how to call it from our Golang bindings so that our server can decide when to go ahead and mint tokens. We're going to dig a little bit deeper still with the mint function to talk about, okay, the bindings that Go Ethereum, the public repo, gave us are great because they do all of those things that Ilan mentioned all at once. They create the transaction, sign it, broadcast it immediately. That requires that when we make that function call, we have the private key that can mint tokens ready to go in the server that's making that decision. From a when we really do this, everyone in the space will actually do that signing in a more trusted way that involves a different system. And I think this is a good example of something where everyone's actually doing something else, and the open source code here doesn't capture it very well. So that's why we wanted to dig in here and talk about, okay, how do we actually create an unsigned transaction that can be moved around, and then what does it look like to sign that transaction? And then once we've signed it, come back and decide to broadcast it on the blockchain. I'm going to talk a little bit about signing in general quickly. So signing is what provides the auth, both the authorization and authentication on the blockchain. How this works is, I won't go deep into the signing primitives, but the person who is publishing the transaction, which is like the from address, has signed that transaction, and it's possible for anyone else in the world to verify that they have signed that, to verify that the signature that they put on there maps to the public key that maps to their address, the address of the sender. And so when we're transferring tokens, it's the person who is debiting tokens, who's losing tokens, that has to sign the transaction to authorize that they're losing those tokens. So that's what's going on here. Here the mint function is a little bit more complex, where we're saying there's an owner of the smart contract who can sign a transaction to say that we increase the number of tokens and that they go to a certain destination, which is obviously a very important operation that we want to be secure and only be possible from the actual owners. The other bit that we're splitting this out into is broadcast. There's actually a lot of complexity here. There's sending the transaction out to an Ethereum node. We have our local blockchain that works as the single node of our one blockchain. But you can send your transaction out to any node, and what happens is it communicates it to all the peer nodes throughout the network. And eventually a miner picks up that transaction and decides to mine it into a block that is then, once a miner who picked up your transaction wins the race to mine a block, then that block is published back to the network, and then your transaction is actually part of the public ledger. So this is a very asynchronous process. Your backend needs to be able to send it out to a node and then look and wait until it's been published on the network, and then maybe even wait until there's multiple other blocks beyond that to be sure that the transaction history definitely won't change. To talk a little bit about that, so blockchain mining, this is what creates new transactions. The process involves brute force protection against changing history, because it's an expensive search problem that the miners are doing to win the block, and it's very expensive to write blocks that are alternative histories to the one that is the winning history. The part of that is fees. I'm still not going to go into too much detail here, but it is a market that to some extent the miners benefit, and when the demand is high and when the demand is high, the fees end up higher to put some back pressure on users to fit the fit the demand to what the throughput of the blockchain can actually handle. Jumping to, so we talked about signing, we talked about broadcasting. Exercise 3, again, is about splitting that mint function into creation of the transaction, signing it, and broadcasting it. So if you jump to the exercise 3 branch, it will have a lot of the setup ready to go for you. I'm gonna, and you can look for this mint with explicit signing function in the code in mint.go. And this is actually a pretty simple exercise. So if you're still haven't finished exercise 2 or exercise 1, you might take the opportunity to just jump up to exercise 3 here, where the challenge here involves doing the create transaction, sign it, and broadcast it, all 3 separately. And again, we can test it with go test, test mint. And that test will require Golang as a dependency, but not much else. So, so we should be able to have people jump ahead and catch up on this one. And we'll again leave a few minutes to dig in and help out with any questions that there are. I'll even jump to the code from the right branch this time. So I have pulled down exercise 3. I'm going to the code. So we finished the smart contracts in exercise 1. Now we're deep in mint.go. This file has some has the private key of our owner. We might store that differently in a real server setting. The mint function has now switched to calling mint with explicit signing instead of mint with bindings. And so that go test will test that works. Here's the mint with explicit signing function. And if I'm going to jump to I'll copy this. If I jump to the terminal and run the test, I should be able to see a result. So this says that there was a failed assertion that it expected 1.5 tokens, but 0 were minted, and it says make sure to sign and broadcast a mint transaction. So here's the failing version of the test when I haven't filled in the function. And then the challenge there is to fill it in. All right. Give a few minutes and let us know if you want help there. As I mentioned before, the repo for this talk will remain a public repo, and the slides are linked from there. So if you want to go back to any exercises or go through this with your friends, especially the ones that are looking for jobs, you can do that later. And but we're happy to help now. This is kind of the last exercise where we're digging in the code. A fourth exercise is more of having everyone put it all together for the demo. So we'll I'll kind of just guide through that one more. All right, is anyone still working on exercise 3? I'll maybe spoil the solution here soon if there's no last words. Cool. So the next slide has a screenshot of the code with the answer. So this has 3 function calls here in the Golang. There's create a mint transaction. This X that comes out of there is that unsigned transaction. The benefit of having that separated out is you could put that over the wire as a JSON or whatever to be able to pass around that unsigned transaction to whoever it is that needs to sign it. And whoever needs to sign it, they could do it in Golang. It doesn't have to be in this server. That was the big goal we had here for exercise 3, was to split it out so that we could imagine signing outside of the server. And we have a helper in there that you can check out to sign the transaction. And then the broadcast function is pretty straightforward. I'll actually jump into the code to talk through these a little bit, since I don't have a screenshot. I'm going to jump to the exercise 4 branch so that I think I'll have the solution. Yeah. So there's create mint transaction. This is a helper we've included in here that actually packs the data for the smart contract call, pretty explicitly. So that's an interesting one. And then after that, puts together, calls the blockchain to decide what nonce should I use, what fee information should I use based on what happened in the last block, and puts all of that information into a transaction that has a similar structure to the one that Ilan talked through earlier. So that's the transaction creation. And then the second helper we included here was the sign the transaction. This is a pretty straightforward use of the bind package from Go Ethereum, which we're leaning on very heavily here. And then broadcast is also a very simple usage of the Go Ethereum, which, yeah, cool. All right, jumping back. We've created virtual dollars. That completes writing the code. We have the pieces all there. There's a smart contract. We can deploy it. We can mint those mint those tokens by broadcasting a mint transaction. What we're going to talk about now is completing out our demo by giving an example of an external wallet, and we're using Metamask for that because it's pretty easy and it's clearly separate from what we've built. So it's kind of signals that it's a separate external wallet where someone can just hold their new USDK tokens. So I'm going to jump to that. We're calling this exercise 4. It's more of a guided exercise that has screenshots of where to go and what to do. So there's not a separate solution here. I'm just going to kind of demo it and walk through. So the main dependency here is to go and install Metamask, which is a Chrome extension, and then once you're in there, it's just a matter of creating a test wallet and switching the network to localhost, which is the one that you can run in the Docker container locally here. So I'm going to jump back to my terminal on the exercise 4 branch and show some of what's going on. Actually, before that, so I've already installed Metamask, but I forgot the password to this. Once I'm going to even demonstrate making a new wallet, which actually, what can I do here? Oh man. Maybe. I feel like they change this UI every time I use it. It used to be. We're gonna jump machines to. All right, cool. Just pop in.
All right, so I'm just setting up the local environment. We have the local blockchain, the bottom right there. We have the back end, bottom left. We have the front end, top left. And then I just deployed our contract to our local blockchain here.
Yeah, I think we need to add a bit more documentation about remembering to deploy the contract, but it's this go run command deploy that gets you there. And then, do you want to demo that bit, or?
No, take it.
Okay.
Yeah.
I'm going to go ahead and add, so there's in Metamask, you can add a token, and to add that there, I need to get the smart contract address. That gets output both on the chain and in this script that deploys the contracts. So once you've deployed it, you can grab that address. It is deterministic, and we've got it documented in the repo, but once we tell our Ganache about it, it actually looks on chain and finds that there is a contract there, that it has symbol USDK, and it has 18 decimals. So that's great. Add that token. I have this account has 0 ETH in it, as well as 0 USDK. What we want to demo here, once we've started up the blockchain, deployed the contracts, and started up the back end and the front end, then we can go to the front end and use it to mint some tokens and see them arrive at our our personal MetaMask wallet. So jumping to this UI at localhost 3000, I can continue the demo a bit of what I teased earlier. So let's put another $500 into the system. Maybe I'm doing a wire into your new backend, or however you're using open source tools to receive dollars. That updated the state so that there's $500 on platform. Now I'm going to go ahead and withdraw. I guess we want like amount to withdraw rather than amount to withdrawal here. But the address that I'm going to use here is going to be the address on my account 1 in this MetaMask wallet. So it has a convenient way to copy there, and doesn't even show the full address. So there's not a way to do a more manual copy. And this is going to attempt to put $100 worth of USDK, 100 USDK into that address by minting it on the back end. When I submit, the UI updates. Can see that there's $400 in USD on platform. 100 of it is now minted as USDK with $100 in reserve. The idea is that we're holding those $100 somewhere in reserve so that when someone comes back with the token, they can redeem for $1. We can see that the backend did the withdrawal. We can see that a transaction went on the blockchain, and most importantly, we should be able to go to our MetaMask wallet and see a balance, 100 USDK. So, yeah. So that's the demo. We have put something together that mints 100 USDK. The exercise 4 here is just about going through that yourself by installing MetaMask. I don't know if we want to give a little time or check in. Just go for it. Okay, cool. Yeah. Is anyone messing with that and want to stop in and get help? If not, this slide, I think, summarizes where to go. There's make your local, make the back end, make front end. Deploy the contract was forgotten here, but the commands, I'll even highlight one more time, which was go run command deploy. And then, yeah, should have your own very own USDK. Cool. We're kind of wrapping up here. Other topics that we didn't cover are, well, I got into reserve baking a little bit, that you really do, if you're having a one-to-one stablecoin, hold those dollars somewhere and do it in a trusted way. You can come ask us about how Paxos does it. Handling token deposits, we did the mint flow, but not the burn flow of tokens. That's a whole different set of work that involves watching for deposits. Connecting to nodes and real blockchains isn't too difficult, but there's plenty to talk about there too, as well as taking fiat deposits and fiat integrations. So lots more that goes around this, but that's it. Thank you. Yeah.
Yeah, we have some time left, so if people have questions, we can stick around for 15 minutes or whatever for anything that you guys are interested in, either about the exercises, about stablecoins, about crypto, about Paxos, whatever you guys want to talk about. We've both been in this space for about 4 years, so we've seen quite a bit of change. And then, feel free to reach out to us. We're hiring. Take down our information. Talk to us throughout the conference. We'll be here for both days. I did see a hand in the back. Oh, do we have a mic maybe for questions?
Oh, okay. So how does withdrawing work? Like if I want to now exchange a token for my cash, presumably there's a transaction fee there. How do you bake that into the contract?
Yeah. So putting a transaction on the Ethereum blockchain costs a certain amount of Ethereum, and that amount of Ethereum is just determined by the network. So we would want it to be as low as possible. There's an opportunity there to charge an additional fee that goes to the token issuer or the owner of the smart contract. We're not doing that here. So there's actually, there's not really anything special to do to introduce the concept of the fee, but as the person trying to move the token around to transfer it, you do have to have Ethereum in your address that you're going to send from. And
I guess I'm talking about converting it back to USD cash money.
Yeah. So
the deposit flow, how would we accept? How would we accept it and then burn it and then be able to withdraw?
Yeah, exactly. Yeah.
Yeah. So that flow, Ilan's going to an address that does have some ETH, so it could make a transaction. The holder of the token would make a transaction to transfer those tokens to an address held by the issuer, and the issuer would see that and say, okay, you sent me the tokens, now I'll go ahead and burn them and give you the dollars. And that's how we do it with our stable coins. Does that make some sense? Cool. All right. Any other questions before we wrap here? Yeah.
So how do you guys handle price fluctuations? Because I know it is 1 to 1 peg to USD, but in reality it's 1 to 0.999 something.
Okay.
Yeah, so because we are always redeemable 1-to-1, any arbitrage that exists on different exchanges will be pretty quickly arbitraged away. So if, for example, there is, let's say a huge drop in price of Bitcoin, people are trying to sell and get into something more stable that isn't as volatile at that moment, they may choose a stable coin and they may choose ours. And so that could draw extra demand to that particular stable coin, which you would imagine it to go up in price, right? If there's an increase in demand, but a stagnant, amount of it out there, then you would have to, or you would expect the price to go up. So in that case, because we are 24/7, because we have integrations with different market makers, they're able to quickly, deploy millions of dollars to these different exchanges to level that out. So any fluctuations that happen in price are automatically resolved by the market through incentives such as arbitrage. And it stays pretty consistent. As long as your token has wide distribution, it's pretty easy to stay consistent around $1.
How do you guys solve that problem?
What was that?
Yeah.
Yeah, so the question was, how do we solve the problem if it's not widely distributed, or how do you kind of bootstrap that? It's really partnerships. You have to have the relationships and try to get out there. And then also, as long as you provide the ability to redeem or create, minting is probably more important than redeeming, there will be opportunity for someone to make money there, and they will find a way. So there are plenty of stablecoins that are much smaller and still have a decent peg. As long as they provide that ability, if someone can make money off of it, they're probably going to try to, right? So even if it's fairly small in size, you should be able to keep up with the demand as long as you actually allow minting 24/7 and you're able to keep up with it on your side.
Yeah, on launch day, you definitely want to have a relationship with a market maker who will be there. But as long as someone's ready to do it, that's pretty simple.
Great. Any other questions? We have about 10 minutes left and happy to chat about whatever. Yeah. No, we can't hear you.
That's all right. We may have to continue without it.
Yeah, I can hear you if you talk about it. Let's repeat the question.
So, what did you get out of creating? You said you could tax dollar as a stablecoin, right? What did you get out of creating that? Does that play into your relationship with PayPal, or like, why does yours exist? Why does also exist? Sort of.
So we created ours 3 years ago, about.
Yeah.
So it was before any of that. It was before USDC. If you're familiar with them, we actually released around the same time as Gemini. And at the time, there was no regulated stablecoin. So ours was the first. The only other thing that really existed out there was USDT, which is Tether, which has questionable banking practices. And then there were, some crypto native stablecoins such as DAI as well at the time. But there wasn't anything that was reliable that actually had the money in the bank at the time and could prove it and had regular audits. So that's what we were bringing to the market at that time, was this regulatory lens on what a stablecoin could be.
Yeah, I think that's still a lot of where the competition lies right now, is on what the right regulatory framework is for a stablecoin.
Yeah, we actually.
And a lot of the differences that still are that.
Yeah, we didn't mention it, but ours is regulated by the NYDFS, the New York Department of Financial Services, and they have a very strong oversight over everything we do. And we have monthly attestations to make sure that that reserve amount is true by a top 10 auditor in the space.
There's,
Yeah.
yeah, that definitely could talk more about that. But.
Yeah. Yeah, please.
This is more speaking of test 3, but in running the test, getting like a intrinsic gas too low error. I don't know if that's, it says half 0, 1, 21,632.
Cool. Yeah, do you want to just go help him right there?
Yeah, sure.
I split the check
All right, we may have to look then at the code. I don't know if that's something we can live debug in 5 minutes. But happy to do it after.
What were you trying to do? Sorry.
Just,
I'm just trying to go test after updating like exercise 3 code. I'm just trying to go test out.
Cool.
That was like something.
we may have something in the gas that's a little weird. We'll have to check.
Yeah.
Where would I find the token contract address for the token?
Sure. Yeah, so you'll see it when you run the deploy, right? We get spit out the owner of that particular contract and then the contract address. And also in the, oops,
You just scroll up there. Yeah.
yeah. In here, how do I page up? Nope. I'll just scroll. In here, this is our ganache, right? And this is our local contract. So you also see that the transaction down here created that contract. So you can grab it from either way. You can also programmatically figure it out. It's based on the deployer and the nonce. And there's some helper methods that are out there, or libraries that can help you figure that out too. Great. Any other questions? You guys enjoy it? Were you able to deploy? All right. Cool. Well, thank you all so much. We're around both days. Definitely come talk to us. We are hiring.